All right, on this video, we're going to continue working through this worksheet here. We're going to start on number 12, and we'll work through these problems. Hopefully, they'll give you some understanding of how to go about using the payment function on the time value money calculator. So number 12 says you work for Ford Motor Company. Recently, R&D, research and development, indicated a new design for the Ford Focus that allows GPS in the steering wheel. First of all, this is a horrible idea, but however, let's continue. The cost of putting the GPS in the steering wheel is an extra 1.5 billion in manufacturing expenses. The sales department has estimated the new technology will bring in an additional $700 million in revenue each of the next 3 years. As an alternative, Ford is holding a portfolio of energy stocks that is likely to earn 12% over the next 3 years. And the question is what should Ford do here, right? They can either invest in the new technology, and we see what the cash flows from that new technology are going to do, 700 million in each of the next 3 years, or they could take the amount of money that they would have invested in the new technology and instead invest in a portfolio of energy stocks. We're going to solve this two ways. First of all, we're going to solve I think the easiest way to understand this is we're going to solve for the rate of return of the technology investment, the GPS and the steering wheel, and compare that rate of return to the rate of return that is expected if we invest in the energy stocks. Okay, so this becomes a pretty straightforward question. I'm just going to say equals rate. And what I'm going to do here is the number of periods is going to be 3 years, and I'm going to introduce this payment function. Okay, and at this point, I want to ask 3 questions, and I'm going to ask these 3 questions whenever I'm solving time value money calculations. First, what am I solving for? So in problem 12, I'm solving for rate. The second, what I want to ask for is how frequently does interest compound? All right, and in our discussion in class, interest is going to compound as frequently as payments are being made. Okay, and so in this case, the payment that Ford is going to receive is 700 million in each of the 3 years. So interest is going to compound annually. That's important, and I'll explain why here shortly. And then the last thing we want to do is we want to talk about what are the outflows versus what are the inflows. Here, the outflow is going to be the 1.5 billion, right? That's coming out of Ford's pocket. The inflows are going to be the 700 million that are going to come into Ford's pocket. Okay, so the 700 million is going to be an inflow, so that's going to remain positive. Okay, and so when I put 3 years, 700 million, it's going to capture all 3 payments of 700 million in each of the 3 years. All right. Next, I'm going to put in the present value. That's an outflow of 1.5 billion. So I'm going to say negative 1.5 billion. Make sure you got the right zeros there. Okay. And then the next thing I have to input is the future value. Now, notice something here. Because we have said that 3 years, right? We have 3 years of a payment of 700 million. That's capturing all of the cash flows. So here, future value is going to be 0. Now, there might be problems later on where we have a future value, right? Where maybe a company invests in new machinery and that machinery is going to produce some amount of new cash flow for 3 years. And then at the end of the 3 years, we sell the machinery for scrap or something. And that sale, or the amount that we get from the sale, or the salvage value from that scrap machinery, is going to end up in the future value. However, here, the problem doesn't give us any future value, so I'm going to put 0. I'm going to compound at the end of the period here, and this is going to give me my rate of return. And I'm going to double check my math to make sure that I didn't input too many zeros. So let's see here. This is probably a good exercise. And it looks like it's 19%. In fact, let me add some decimal places here to make sure it looks all right. So it looks like the rate of return is going to be 18.91%. That means the rate of return by investing in this new technology is going to be greater than the 12% return I can receive on this portfolio of energy stocks. And so using the rate of return here suggests that Ford should invest in the new technology or the GPS in the steering wheel. All right, I'm going to solve this another way, and it's going to be less intuitive, but it's going to be important for the next chapter that we discuss in class here. So what I want to do also now is I want to take the present value, right? So here is years 0, 1, 2, 3, where year 0 is today, right? And this is going to cost me 1.5 billion today, but the cash flows that are going to come in is going to be 700 million in each of the next 3 years. Okay. So what I want to do is I want to take the present value of these future cash flows and then compare it to the cost, where the cost is the 1.5 billion. So I'm going to solve this problem in another way. And the reason that I'm doing solving this problem in a less intuitive way is because I'm going to introduce a new concept called net present value later on that I think will be important. To calculate the present value of the future cash flows, I'm going to say equals present value. Now, the rate of return here is going to be the rate of 12%. Okay. So again, this allows me to compare the rate of 12%. I've got to earn at least 12% on this investment. Okay. Why? Because this 12% is what I can earn if I invest in a portfolio of energy stocks. So I'm going to use that rate of return. I'm going to call this more of a hurdle rate. This is a hurdle rate or a rate of return that I have to get. The lowest rate of return that I have to get is this 12%. We call this a hurdle rate. So I'm going to put that in as my discount rate when I calculate the present value of these future cash flows. Again, the number of periods is 3 years. The payment is 700 million. The future value is 0, and I'm compounding at the end of the period. I'll let that sit for a second. Again, what I'm doing here is I'm calculating the present value with a discount rate of 12% because that 12% is the lowest rate that I can accept. Here, that allows me, when I put in the 12% for the energy stock portfolio rate of return, that allows me to compare the technology investment, the GPS and the steering wheel, to the portfolio of energy stocks. And there you can see that the present value of the future cash flows is 1.681 million. The difference between 1.681 million and change and 1.5, I'm sorry, that's 1.681 billion, and 1.5 billion is going to be 181 million. Okay. And so this calculating the problem or solving the problem this way is less intuitive, but it's going to be important going forward because I'm going to introduce a new concept here later on. And if you're comfortable finding the present value of future cash flows, this will be useful. Okay. Let's solve the next one over here. So suppose you don't work for Ford. Oh, by the way, let me pause. This is a horrible idea, right? Phones have GPS. Cars already have GPS in the console. Why you would want GPS in the steering wheel, that would be a horrible idea. And the point of having such a dumb idea as one of these problems is to help you remember that finance is providing you some guidance, right? So the numbers are giving you some guidance. The numbers should not make the decision, right? Humans should make the decision, and those decisions should not just be made based strictly on numbers, but also some intuition. Who wants a GPS in the steering wheel, and all of a sudden, if you get in a rear end accident and your airbag comes out, you're going to have the GPS unit smash up against your face? This is horrible idea. I would not invest in the GPS, even though the numbers tell us to. Okay, let's solve number 13. Suppose you don't work for Ford, but you want to buy this cool Ford Focus with GPS in the steering wheel. You can afford a payment of $546 a month, and the bank is offering auto loans on the following: 6% per year for 4 years. The current cost of the Focus is $21,498. Will you be able to buy the car? Okay. Again, we can solve this 2 ways. The first thing we can do is we can solve for how much of a payment we can afford. Look, we need a loan for $21,498. So if we go into the bank and we get a loan for $21,498, that's going to be a present value. Okay. And again, what are we solving for? We're solving for payment. How frequently is interest going to compound? Since the payments are going to be monthly, interest is going to compound monthly. Okay. And what are my outflows and what are my inflows? I go into the bank and I receive 21,498. That's an inflow. That's a positive number. I'm going to be paying the bank a payment every month. That's an outflow. That's going to be a negative number. Okay. I walk into the bank, 21,498. I'm solving for payment. The future value of this loan, not the car, but of the loan, is going to be zero. At the end of the 4 years, I will owe zero amount on the loan. So I'm going to say zero equals future value. Okay. I'm going to take 6% and divide it by 12 to get the monthly rate. Again, I have to transform the monthly rate into the annual rate into a monthly rate because interest is going to compound monthly. And that's 0.5% per month. And I've got to do something here for 4 years. So how many months are in 4 years? I'm going to take 4 times 12. It gives me 48. I'm going to enter that into N, and I'm going to compute the payment. Okay. This is going to come out as a negative number because it's an outflow, but it looks like the payment is $504.88, which is less than the $546 that I can afford. So it does look like I'm able to afford this Ford Focus. Okay. So that's one way that we can solve it. Another way that we can solve it is just solve for the present value instead of solving for the payment. We know we can afford $546. Okay. So let's do it this way. I know I can afford $546. That's an outflow payment. I know I'm going to owe zero amount on this loan after 4 years. The interest rate is 0.5% for 48 months. And now I can compute present value. It's going to be an inflow. It's going to be positive, and it's probably going to be a number greater than the cost of the car because I already know that I can afford it. So it looks with a payment of $546, I can afford a car, or a loan rather, of $23,249. Okay. So there's 2 ways that we can solve for problem 13. I think that's important. So we can use this payment function to calculate loan payments. We can use the payment function to calculate the present value of future cash flows. So it's going to be useful. Let's continue. Number 14 here. So say you have $2,000 balance on your credit card. The minimum monthly payment is $32 a month, and the current annual rate is 18%. How many years will it take to pay off the credit card if you make the minimum monthly payment? All right. So this is going to be an important problem. Let's talk about this for a second. What are we solving for? We're asking how many years it will take to pay off the credit card. So we're going to solve for years. How frequently is interest going to compound? Since I'm making a monthly payment, interest is going to compound monthly. And what are my outflows and what are my inflows? Now, this is important. When you use your credit card, you swipe that credit card. It seems like magic, but what you're really doing every time you swipe that credit card, you're getting a loan from the credit card company. So if you have a $2,000 balance on your credit card, that means that the credit card company gave you a $2,000 loan. That was an inflow. All right. You're going to be making these minimum payments to the credit card company. That's an outflow. So the payment will be negative. And the future value of the loan when you pay it off is going to be zero. Okay. So let's do that over here in Excel. Again, we're solving for the number of periods. My interest rate is 18% per year. However, I need to divide that by 12 to get a monthly rate. I can do that in my head. That's 1.5% per month. The payment is -32. The present value is 2,000. The future value is 0. I'm going to compound at the end of the period again. At the end of every month, the interest will compound. I'll let that sit for a second. All right. And this is going to give me the number of periods that it's going to take to pay off the loan. Let me ask before we solve this, is it going to take, or is it going to tell me the number of months or the number of years? Hopefully you said the number of months because I've transformed everything into monthly payments. Now, what do I need to transform into monthly payments? Again, my present value, my future value remain the same, but anytime interest compounds more frequently than annually, I've got to change my rate, I've got to change my payment, and it will change my number of periods. So it looks like it's going to take me 186 months to pay off this credit card debt. I'm going to take that number and divide it by 12 to see how many years it will take me to pay off this card. 15.52 years. All right. In fact, if I multiply 32 by the number of monthly payments, I'm going to end up paying over 15 and a half years. I'm going to end up paying almost $6,000 to pay off this $2,000 balance on the credit card. Okay. That's hopefully that's insightful. You probably should learn not only how to do time value money calculations, but also how interest works against you, particularly in credit card debt. All right, we'll stop that stop this video here. We'll pick up where we left off in the next video. So hang tight.